Welcome to the second video in our aerodynamics series. Today we are going to understanding airflow, the basics of pressure distribution in aerodynamics. In this video, we will dive into the fundamentals of airflow, how it interacts with objects and its critical role in shaping aerodynamic performance. Let's get started. Why is understanding airflow so important? Airflow governs the forces acting on objects moving through air, such as lift, drag, and stability. This knowledge is the foundation for designing aircraft, car, and even rockets. Without clear understanding of airflow, creating efficient and safe design becomes nearly impossible. Let's begin with the streamlines, which represent the path of air particles as they flow around an object. Airflow can be smooth and predictable, which we call laminar flow, or chaotic and energy intensive, known as turbulence flow. There is also a transition zone where the flow shifts from laminar to turbulent. Understanding this pattern is critical for predicting performance and efficiency. Next, we have Bernoulli's principle, which explains how air pressure varies with the airflow speed. Essentially, faster airflow results in lower pressure, and slower airflow leads to a higher pressure. This principle is vital for the understanding lift generation. For an example, an aircraft wing shaping creates faster airflow over the top of surface, reducing pressure and generating lift. Now, let's look at the continuity equation. This states that the product of airflow velocity and cross-sectional area remains constant. As an example, in narrow nozzle, airflow speeds up because the area decreases. This principle helps us to understand how air moves through different geometries and its implication for design. Here, we see how airflow interacts with an airfoil. Notice the pressure difference between the upper and lower surface of the wing. This difference is what generates the lift. Smooth airflow is critical for efficient lift generation, while disruptants like flow separation can reduce performance and increase the drag. Let's talk about simple experiments to visualize this concept. For example, take a piece of paper and blow over it. You will see it lift due to Bernoulli's principle. You can also use a small model in front of a fan or visualize airflow with the smoke in wind tunnel. These hands-on activities help reinforce theoretical concepts. How do these principles apply in the real world? For starters, aircraft wings are designed with a specific shape to optimize airflow and maximize lift. These principles are also used in automotive design to reduce drag and increase fuel efficiency. Wind tunnels play a crucial role in tracing this design across the various industries. To wrap up, let's recap the key takeaways. Airflow patterns, laminar or turbulent, significantly impact aerodynamic performance. Bernoulli's principle and the pressure distribution are essential for lift generation. Understanding these basics lays the foundation for exploring more complex aerodynamics concepts like lift and drag. That's it for today. If you have any questions or you want to share your thoughts, drop a comment below, and don't forget to tune into the next video where we will break down the forces of lift and drag in details. Thank you for the watching and see you next time.